This will be a video demonstrating a 2D refractive error. That is where there's just farsighted without any astigmatism. Initially, your first step of the T thermometer reading is to find a T thermometer that contains a central white space in its widest segment, and that is identified as the one in the middle. If you expand that, you notice it's not disappearing after your quick release. Whereas the one before, it brings it out, but it disappears after your quick release, indicating this is currently your narrowest thermometer to contain a central white space. Now, while you're attending to that central white space, the first thing you're going to do is rotate the phone. Well, you can, if you wish, you can move closer to the phone to assure yourself that even though it gets clearer, easier to see, the blue and white, the blue and red lines remain blurry, and further the same thing. But most of these farsighted, once you've established you're already farsighted, you're really just determining whether you have astigmatism or not, separating 2D from 2E. As with 2E refractive errors, first thing you want to do is rotate the phone one direction to see if the central white space is either getting narrower in one direction or wider in the other. And as you rotate the phone in either direction, you see it's staying about the same size. If anything, when you rotate one direction, you can see the blurs actually widen a little bit, narrowing the central white space, which occurs at the same if you go this direction, which is typical of 2D refractive power. Now, in order to neutralize, let's just say we did have astigmatism, and we want to neutralize or align our phone along our astigmatism axis or spherical axis. The way to do that is to continue rotating the phone while staring at the central white space and trying to get the central white space at its brightest, widest, or at its most clearly defined. That is often where the blue line or the upper or nasal line also becomes slightly at its darkest as well. And so as we're rotating the phone around, we see that at some point we've crossed that where now the central white space is getting duller. And we move back, we can see it brighter, continue to get brighter, and then duller. So, and if we should also notice if we move, paying attention to the darkness of the blue line, if it gets lighter going that direction and lighter going that direction. So you can see the blue line is at its darkest, exactly where the central white space is also at its brightest. And that's right here. So now we've aligned the phone along the central, along its, usually it's 35 to 135 degree axis if you have 2D astigmatism. This can be confirmed by quickly scrolling down to the astigmatism axis target, where we can actually measure how the phone is aligned by placing a ruler exactly through the center of the phone. Now, because of the near side or the far sightedness, at your standard reading, this can be pretty blurry, but I can tell you that it's exactly aligned along 135 axis by putting a pair of reading glasses and looking straight across. So that confirms that we most likely have 2D refractive error as well. Now, to prove it, what we're going to be doing is going back up to your T thermometers, and we're going to be comparing the width of after we maximally widen it to get our central white space back again. We're going to be placing a ruler below that segment that we're looking at, and we want to make a memory of the width of that central white space, and then we're going to rotate the phone to make the ruler exactly vertical to you. And again, recognizing that the width has not changed or is exactly equal between our two axes, our two visual axes, doesn't change at all, defines that there's no astigmatism present, and that the refractive error is 2D.